All right, perfect. Yeah, it's starting already. Then I'm just gonna move this there. Okay. So, all right. So first, again, our goal is to make a NOR gate, and let's hope we can finish it in an hour or an hour and a half. If I can't finish it that time, I'm not good at analog base. Anyway, so what we do is gen new. When we make a new generator, it always has to be the name NOR gate underscore gen, right? Because you always need that underscore gen requirement that Martin said. It always has to have that underscore gen. Okay, and then if you make it, it's supposed to create a directory, right? And how do you verify? We have to see that NOR gen here. Yeah, yeah, easy peasy, right? Okay, and even in PyCharm, if you open the Virtuoso template, the home directory, the NOR gen is there. All right. Okay, so there are. Do you see it? NORGen. Okay, perfect. In the NORGen, we can open inside the NORGen. We can immediately open the four important files: design, layout, params, and schematic. Okay, so I'm gonna put it on the side here for a while. Move to the right. Oh no, that's the NAND gate. Nor, nor, and then another nor. Right. Okay. So first things first is the setup because Martin did not fully automate everything yet, right? So we have to put, let's say we go to design first. What Martin did with Gen new is that he copies T gate and makes another T gate. All right. So to verify, you can see the T gate here. We can change everything, all the T gates into, NOR gate because that's what we need, right? Oops. So I'm gonna change it very quickly here. T-gate params. I'll just make NOR gate params. Control R. Control R. Oh my god, that's so good. Okay. NOR replace all. Yeah. Oh, hold on. I have a bit of a. Oh yeah. Let's just do that. No, all T-gate becomes NOR. NOR. Okay. So everything there. Then you have to do the same for the schematic and stuff. Hi, Dr. Mir. Okay, so you have to change all those T-gate stuff. For not only in design, schematic, layout, and params too. Okay, so T-gate, nor replace all. I'll do the params too. I think the params has also. T-gate, replace all. Yep, that's pretty much it. In layout, T-gate, also nor. Okay, there. As long as we change all the T-gates into nor already. I forgot to open Virtuoso because we need that thing. Sorry. Yes, there should be a template generated. But you open Virtuoso first, and then you do that. You modified all T gates to NOR already, right? And just to sanity check that nothing changes in the path, you can make that gen make. The gen make NOR gen, right? Then if you hello, oh you have to go. Oh, okay. Bye. Okay, where were we? Ah, Jen make nor Jen, just to sanity check if he did it correctly, right? If he did not, oh no, something did mess up. What's this? Oh, nor params. Where did we? Where is this? Design PY. I think I changed something. That's not supposed to be changed. Ah, this one. You got it? Yeah. I changed something that wasn't supposed to be changed. Whoops. More params. Yeah, it's supposed to work. Yep. Okay, and then this appeared. This is where. Yeah. You ref. You run it again just to be sure. Okay. To have the layout. Okay. Oh yeah, yeah, yeah. Ah, in the virtuoso window here. Oh, there's also there. Oh, so you got the layout, Oshin? Yeah, okay, so that means we did not mess anything in the paths. Okay, so that's perfect. Okay, now we can make our NOR gate. But I will cheat a bit because I like to, since I was new in this layout stuff, I took out all the dummies and I just placed the NOR, the NMOS and PMOS transistors. Okay, that's pretty much it. Uh, yeah, while it's running, we can go back there anyway. Ah, okay. So your question earlier is how the flow is. Personally, I think the best one is to start with the schematic. Yeah. Oh, and to move here. Okay. So, but what I do is I'll delete the symbol first because, I can just create a new cell view, right? So, I did the symbol. Oh, I realized there's, yeah. Oh no, I realized Norgate has several, whoops, file make editable. Norgate has several transistors. Oh, so that I can demonstrate how you place the columns. Right, okay. I'll, I'll give you a heads up, but my method of, placing the transistors isn't really very automated way. I'm doing it manually because, the way you position transistors is by fingers. That's why. So you have to sort of estimate it. Oh, you. Yeah. Yeah, let's use the two PMOS and two NMOS. Oh, I think I forgot to mention to you guys last time, but I think Kumar already knows, but if you every time you import in bag, you have to modify the bag prim library. Do you know that already? This one, this bag prim. Okay. Say for example, you have a new technology, 28 nanometer or 90 nanometer. Uh, you have to modify the schematic files in here. So say for example, NMOS 4 LVT, right? I'm gonna open the schematic. this transistor is using the CDS FF MPT. So, so if you have a 28 nano or some other technology, you have to modify this before plugging in. Yeah. Okay. Right. Because the bag prim is the one that bag uses to generate these schematics, and these transistors here, they're actually from bag prim. Okay. So you don't use directly the technology. You have to use the bag prim technology. At least that's what they taught us. Aha. Actually, you know what? Now that I think about it, maybe let's do the NAND gate that I made so that I don't have to type too much. Okay, it's okay with you guys. Yeah, yeah. Yes, I have to make the schematic and what. But just to make you know that you have to fix the schematic first, right? So if I go to my NAND gate here, the NAND template, right? I made my schematic first. I made sure that I have my symbol. Yeah, no problem. Yeah, and in the schematic, you have to take note of the instance names, right? P0, P1, N0, and N1, right? Because this instance names, if you go back here to the NAND gate, I'll close the NOR gate. I'll do it next time. If I go here, okay, in the schematic, right? And you look at this tran info list, those are the names that I use. Okay, P0, P1, N0, N1. Okay. Yes. So in the schematic part, these names, okay, the first uh, element in the tuple is from the schematic. These ones, okay, I actually modified this based on the params, if I'm not mistaken. Oh, let me see. I might be mistaken. Sorry, this names here. Okay, take note of it. It's like a naming scheme, but I use it also in layout. Okay, because the same one. Okay, these ones again. I'll repeat. These bigger ones are the names that I use in the schematic. The smaller ones are the names that I assign to my transistors in the layout. Right. So that's the one. That's the first step that you have to do. Like after making your schematic, after making your cell view, in the schematic file, this is the first thing that you're gonna set. Okay. For the params, I think I explained last time that and it's really up to you what you want to put in here. Right. You can modify like specific fingers for parts. The params is just the dictionary of variables or parameters that they're gonna use for your design. For this example, I did not change anything. Yeah, the yeah, okay. Good question. So if you're asking about just the PMOS and NMOS fingers, the way Martin created these parameters is this part, this seg dictionary. So if I change this like I don't know 32 and this one is like 64, the number of fingers automatically changes. And then they oh I am not sure here too, but I think Martin did mention that it's about something about aligning the first and foremost use an even number, right? The second part is I think it has something to about aligning the yeah. It might be the same motivation too. Yeah, the reason. But I tried not divisible by four. It's fine. It works still. Yeah. Yeah. The reason why. Oh, maybe that's because no, because there was this part before where they had a code here that says, "Hey, don't use anything, don't use the number, or rather, make sure the difference in the fingers of the PMOS and NMOS are multiples of four." There was an yeah, there was a condition here, some error. Yeah, I took it out here and it's still LVS clean. Yeah. Okay. So I think it's just for the example that they put. Okay. So I hope it answers the what you're asking where to start, the schematics part. Okay. So first, again, the parameters, the schematic, the design, you just don't change much, but just the parameter names. Okay. And then here you begin with the layout. Okay. Now, I prefer when I was working on this, I did this step by step. Okay. So what I'm gonna do instead is I'm gonna comment out all of these up to the draw base here, just so that we understand what the first lines of code does. Okay. So like comment everything just after the draw base. Okay. So you are you gonna comment yours? Oop. So anything below the draw base, do you see the draw base line in yours? Oh, I'm using my NAND gate, so it might be different. So for the part that you need to okay, so the reason why I commented it so that you could just see the draw base. Okay. In your part, you can actually if you noticed here, I only have two rows. You can take out the dummy rows if you like. Okay. And if I run this, actually, let's see. Genmake, non-gen. I'll close the other Virtuoso windows because, yeah, I'll work it out later. You could see it's generating schematic and all. It will be LVS fail because, there's nothing in it. But if you open non-generated, look at the NAND gate, right? It's the bare bones, the P channel, the P row, the N row, and the taps. N tap, P tap. Okay? So this, to be honest, I'm not sure. I'm not sure. Sorry. Yeah, Shift F to show everything. Yeah. Which one? Outside? This one. Control X or Shift X. Active dummy. Who are you? Who are you? Okay, I'm not sure. But I only assumed last time. Uh, Oops. Oh no. How do I bring back? Control V? B? Oops, sorry.
No, this is He went inside the. I think you just can close it and open it again.
Okay, I could do that.
Because it's.
I went descend read, something like that. Yeah, okay, I'll try to do this, open this again. Yeah, that's better. Sorry, I don't know how to lay out.
No, so just like when you go inside, you press X. When you want to go outside, press Ctrl V.
Ah, okay, I see. So, what else did I use here? Actually, what I did was, yeah, anyway, it's more important I explain what they did here. So these are parameters, leave this be because I think Martin made that. This is something that Martin made, generate the row for the NMOS, the PMOS, right? And then make it a row list, something like that. This is the part that defines how many fingers you want for your PMOS and NMOS. Because if you remember, the segdict here, the segment dictionary is from the parameters, right? It's the NP, right? So that's the one that they used here. Okay, the divide, well, it's divide by one, but so you can take that out. And then here you declare the transistors that you need. This is the naming. You observe the naming that you do here, right? This is the one for the layout, and when you go to the schematic, it's also the same name. Yes. Okay. So it's like the pairing of those names. Sorry, come again. You mean here? Yeah, sure. I just have to change the schematic too. Yeah, it's really up to you. Okay. Oh, whoops. So that's the one. Okay. And then this is where you specify the number of fingers, right? Because you specify the number of fingers here, you put it in here. Okay. And then here is where you specify, okay, where's my source connected to? Where's my drain connected to? And the naming that I used here, I don't think it needs to be in matching with the, what do you call this? Schematic, the naming scheme, because it's the name that's done inside the design base only. Okay. So that's the one that they do here. They declare the transistors. Okay. Now, this is actually the assignment for the transistors, but let's ignore this first. This is a more important part. Okay. Because this part here, okay, especially FG total, is the one that you put inside the draw base. Okay. And just to make sure we're on the same page, the draw base here is literally this layout. When you call draw base, because that's the last thing we called, right? When you call draw base, it draws the base. Okay. But the size of the width of that base is modified by the FG total here. Okay, the finger width total. Because it again, the sizes, the spacing all are in terms of fingers. That's what they did. Okay. So the finger total here assumes that if I'm gonna draw that, okay, how do I draw that? Oh no, I need a white space. Hold on. White space. Just so that you know what I did with the finger width there. Okay. Whoop. Oh, it doesn't want to go down. Nope. Nope. Okay. I'll put it up here. You can see this, right? So the FG in spacing is something I made because I declared that, hey, I want my transistors to be separated by this much for the sake of example, right? The FG single here assumes the largest transistor, which in this case is the PMOS, right? The PMOS, I declared the PMOS earlier in the parameters to be 32. So that's the largest transistor. So I assume it's the largest transistor. So, oops, my bad. Okay. Oh, come on. Layout. Okay. And then, uh, this FG total, I'm already trying to imagine how much dummies I put, how much spacing I put, and how large are my transistors. So here, this FG total, okay, because it's the total base, what I imagined originally was, okay, I'll put a dummy here, I'll put one transistor here, I'll put a space over here, I'll put another transistor over here, I'll put another dummy here, right? That's why you have two dummies, right? Two dummies, that's the dummies, DD. The spacing in between is just this, okay? And then the transistors are this one. Two transistors, so T1 and T2. But I'm making the assumption that I'm referencing that this entire column is for the PMOS and NMOS already, okay? So if you do that, you get that draw base over here.
I have a question. I go back to the drawing you did.
Hmm.
So is it this what you are doing? Just one column, right?
Sorry, come in. What do you mean one column?
Like the drawing you were making, like dummy, transistor, and then another dummy. Yeah, this one.
Yes.
So this is one column.
This is several, one
Sorry, one
row.
row.
Well, technically two rows because we declared that we have a row for the PMOS upper here and a row for the NMOS, right?
Okay.
But this is the end. Maybe how would I put it? Maybe this is the span of the column,
Okay.
right? And just to give
But
it,
this is
yeah,
the time that they were talking about.
sort of, yes. Okay. Then just to give you an example, what if I took out, let's say, I just say one transistor only, right? If I draw this again, I mean, it's gonna be quick anyway. Or you can watch the live update, right? And you draw it again to go like, bloop, to become shorter. Yeah, see? It became shorter. So basically, that FG total there is just how many columns do you want in that span. Okay? Okay. Good, good, good. Uh-huh. Oh no. Okay. So that's the first part. You draw the base. The tricky part now is this one. Okay. This is where you assign the transistors. Okay. So what we're gonna do rather is I'm gonna draw the transistors next. Okay. But let's try to draw the transistors one by one. Where's my transistors list? I'll put you down here. Okay. Say for example, I'm gonna. Oop. Okay. Let me try to explain this the best I can. This FG column, this the second parameter, tells you how many columns. Okay, because again, all the columns are in terms of fingers width. What coordinate in terms of fingers do I want to put my NMOS into? Okay, and then this FG single, yeah, I'm declaring okay, maybe at the first FG single that you see, whatever that value of FG single is, okay, 32 to be specific because it's the maximum, right? And then FG dummy here is just the offset. So essentially, it's gonna put FG single plus FG offset. That's where you put the NMOS transistor, right? And then of course the alignment, center, left, right, stuff like that. Okay. So for example, if I put hypothetically, let's say, or not hypothetical, but just to demonstrate, what if I made this 0, right? Or sorry, just to make sure, do we have it already? No, there are no transistors yet. I'll run it again just to show where the transistors are. Okay, and in this part, this is a bit more, how they put it? It's a bit more the trial and error side because I couldn't really match, hey, which transistor they put, right? So I did, for example, this is the NMOS, NMOS, PMOS, PMOS, right? So in my code, how do I show you in a very nice way? Whoop. Right? In my code, I said that, okay, my NMOS 0, I put it in some FG single plus the offset. So there's a dummy offset here, right? And then the FG single is maybe a little bit here. Okay, that's why it offset that way. So this is NMOS 0. Now, my NMOS 1, which is this one, is technically, actually, originally I put two times the fingers, right? But then it did not fit, so I put a little bit more. Whoops. So I made it 3 just so that it fits a bit, plus the spacing that I wanted it to be. Okay, so it's really up. This is a bit of trial and error on them on this side, not unless you really count the number of fingers. Okay, so for just to make an example, this is the times three, right? If I make it times two, right, and then I run the code again, you will see that this guy will move to the left because it's not enough spacing. I mean, it's just times two spacing from the relative very beginning, right? So you see that move, yeah. Okay. So in your part, when you were asking like how do you move it here and there, right? In terms of which row, if you say it's in the PMOS row, because if you observe in the code, right? If you say it's in the PMOS row, right? Because you indicate it, like the NMOS should be in the NMOS row, and the PMOS should be in the PMOS row, right? So if you put it in the PMOS row, it's gonna be here. If you put in the NMOS row, it's gonna be here, and then you adjust that finger column to, like how many offset, how many finger offsets do you want it to be? Okay, does that answer your question for this time? Okay, good. Uh-huh. Sorry. Uh, ah, I think you can, but I haven't tried it. Yeah, I think it's
High level.
yeah, yeah. I think they made their own wrappers for that, or maybe it's a BAG2 thing. Or yeah, you're right. I think it's a BAG3 thing. But here, I don't know how to do that yet. Yeah. Okay, so are we clear on this part? Like, yeah, yeah. Okay.
But the thing is, like, I just feel like these dummy stuff and on the code
Mhm.
and FG single whatever, all of this stuff you have to calculate it.
Ideally, calculate it first. Yes. It's like the way Fatima told me about it is you as a designer should already know the exact positions, right? But here, I was not familiar with the really like, okay, which fingers are you really pertaining to? So I did a bit of trial and error, but you have a viewer anyway, so you can always make the adjustments. All right. Okay, so actually, that was almost the last part already. The next part is making routes. Okay, so I'll do this little by little. I will first do this guy and this one. Whoop. Okay, just to demonstrate what a route, how do you do routing? Okay, so this is something made also by Martin. Just basically, it gets what's the index of that row for the NMOS and the PMOS, right? Because that's what you see, right? There's an index for this row and this row. So automatically, you just get it anyway, and you're gonna use it later on. Now, to connect a wire, there are always two things. First, you have to generate the track, and then you have the track ID, and then you make the connections. So the first part is to get the wire ID or the track ID, right? So what is this is that, okay, I want to get a track ID on the N channel using the row and the NMOS row, right? And then I want to get the ones with connected to G. So there are to the gate. So I believe this is the gate here, right? I think that's the one that they use as a gate. Okay. So what he's gonna do is gonna get, okay, I'm gonna get the track ID for this specific row, right? That specific row over there. Okay. And then I'm gonna name it, put a wiring name. And then once I have my track ID, whoops, I'm just gonna connect it. Right? I'm just gonna connect it. So what this does is, okay, I'm gonna connect to those tracks all the connections of my NMOS zero transistor, all the gates of the NMOS transistor, zero transistor to the track number. So it's gonna connect all of those here. Okay. So if I'm gonna run that, just that example, hopefully it updates. Actually, we can do this. We should see a line somewhere here, right? Let's see. Bloop, right? So that's how you make the line over there. Okay. So it's really so. Yeah. Okay. So it's just really two things. Track ID. Not that one. This one, and then the connection. Presto. You're done. We can do it for the rest. Actually. Okay. There's so many wires out there. Okay. What did I do here? You can play around with this, because I think what I did here was to ensure that all connections were made, like all the gates to that gate wire, all the drains to that drain wire. I've seen like some of Martin or Fatima's examples, like they just connected one part of it or so. You could check out the other generators for those examples. Okay. But yeah, that's pretty much here actually. It's the wiring part is actually the most tedious because in my experience, what I did was, okay, I know the wire, I connect it, check one by one. Is it the correct right connection? Okay, and then I keep adding and wire routing all those things. Okay. Now the nice thing about it is that okay, let me see. Um, yeah, I'm gonna uncomment everything. The nice thing, or rather, I'm gonna make my generator again so that we can. So everything I've done those routing, they should appear here. Boop. And then the nice thing about it is that if I change the finger widths, right, it automatically, even the routing is automatically updated. I mean, the way how I wanted the routing to be, at least when I learned how BAG works, it automatically updates. Right? Like for example, this is 16 for the NMOS, 32 for the PMOS. Right? So we can make another one. Let's say, what do you mean information about? Like, it uses. The only thing that Fatima told me was metals 1 to 3 is for internal transistor connections. Metal 4 to 5 is the routing. Yeah. No. But I do know that, for example, where is that? Where's the vertical? Vertical track, vertical track. No, I did not put any information or I didn't use any that time. I think I specified it. For example, this track over here, this is a vertical track, right? All odd numbers will be vertical, all right. And I did specify manually. Like I want to use metal 5 for that. All the other way around. All even will be horizontal. All odd will be vertical. Yes. Yeah, in for layers one, two, three. I actually, yeah, it's in bag. Yes, yes. Okay, so that's pretty much it for that. Actually, that sums up all the connections, right? Okay. So actually, all the connections I've made in my NAND gate, they're also found in Martin or Fatima's example. It's just a direct copy. It's like with a few changes, of course, to what I needed, right? And then what else? Yeah. Yeah. A two input, one output. Yeah. Okay. So yeah, in the schematic, I also had to draw those, right? A, B, and the output O, right? And I did not put the no, I didn't because the example that Martin had didn't require the pin names already. It's like automatically there. Instead, in the layout, PY, this is where you add the pins. Oh yeah, I forgot about that. This is where you add the pins, right? But in the pins, you have to get the wire that you created. Let's say, for example, wire array A is this guy, which I made, which connects all the gates of the PMOS 0 and NMOS 0, right? And then it returns a wire array when you connect the tracks. And that wire array, A, is what you put over here. And you assign a pin to it, okay? Yeah, and then the VSS, VDD, B and 0, the other input and the output. That's it. And then when you match it, when it runs the LVS, it automatically matches. Okay? Okay, what else? Yeah, yeah. What I wanted to show is what if you change the parameters, right? Let's say, how many NMOS fingers do you want? Like 24? And then the PMOS, let's say 48 times 2, right? And if you do that, the live updates, you could automatically see that it's like, bloop, over there. Uh, did it move?
No.
It's not moving. Oh, it's still thinking. Yeah, you see. So the wirings that I made automatically adjusts to. Okay. 24 and 24. Let's see. I haven't tried, but that's a good question. Let's see. Like 24 and 24. Let's see. No, but the yeah, it could be. This dummies you mean here? Yeah, let's see. But we have two dummy spaces on the sides. Yeah, yeah. You only have one way to get it. Oop. Yeah, it's still correct. All right. But there's a space here. Oh, because I put a finger spacing in between. Yeah. Yeah. That's why. As a guy who doesn't know layout stuff, and then for 1 week we're just tinkering at it, and then we look like, does it look correct? Okay. That looks correct. No, okay. Yeah. Okay. Maybe I think you guys like hands on, and if you have questions like wiring and stuff. Yeah. Right. Yeah. Sure. Email or something. Call. Are did I answer your questions? But yes. Yours too. Okay. Yes. Yeah. Did I take an hour? Hold on. Let's see. I stopped recording. 43 minutes. Oh no, but I did not code it from scratch. Yeah, I'm gonna